Welcome back, everyone. I hope you're doing great, every one of you, and I hope you have a great weekend. Okay, today we are going to focus to another section, which is the chi-square test. Okay, so chi-square test here we use in order to do two main things. Okay, so the first one is to do comparisons, the distribution of the data in a category. For example, one nominal variable have two category like sex or gender, so male and female, and some other variable have more than two variables, like a job category. So the variable is job, and inside this variable we have different category like educators, like policemen, like lawyers, like extra. Okay, and the second thing is we use the chi-square in order to do the quantification of the association between two variables. Okay, like an example is that we want to know whether the selection of job, like educators or like cashiers or like a loaner, the bank, the fund loaner, is significantly associated with our gender. Whether male like to do the job related to finance, and the man would like to with job with hard work, something like that. So the second one, we use the chi-square test in order to test whether one variable, the category inside that variable, is significantly dependent on the other variable, other category variable, right? So chi-square test in our focus today is for the qualitative data, and mainly we will practice just only nominal data. All right. So let's move on then. Okay. Okay. So I just make a note. Whatever note you want to make is up to you. Okay. Here. Practice the chi-square chi-square test. Okay, chi-square test. Here I open the brackets for comparison. Okay, for the objective, for the hypothesis, null hypothesis, alternative hypothesis, the principle is the same when we do comparison. Okay, our objective, okay, you can state directly using the word comparison or compare, right? Compare if the distribution, okay, distribution of the data, or the proportions of data frequency of classes in a variable is significant different. Okay, and for the H1, okay, let's say H0 first. Okay, so this is our R program. All right. Okay, please load our data, the car 93 from the previous session. We also practiced this one. Okay. Okay, so I just make a note. Whatever note you want to make is up to you. Okay, here. Practice the chi-square comparisons. Chi-square test. Okay. Chi-square test. Here I open the brackets for comparison. Okay. For the objective, for the hypothesis, null hypothesis, alternative hypothesis, the principle is the same when we do comparison. Okay. Our objective, okay, you can state directly using the word comparison or compare, right? Compare if the distribution, okay, distribution of the data, or the proportions of data frequency of classes in a variable is significant different. Okay, and for the H1, okay, let's say H0 first. But there is no significant difference between the distribution or proportion. Okay, mostly we assess the proportion, the percentage. For example, a qualitative variables of sex. So we have two categories, right? In general, I don't mean for the other specific, like the US, we have more than two categories. Okay, so in general, the variable qualitative variable sex, okay, male and female, we have two categories. So if you go out to do your data collection, for instance, you do a survey of student performance in your class, then there must be male and female student. Okay, and among 30 students, let's say 11 are female and 19 are male. So the chi-square in this aspect, it compares the frequency distribution, whether the 11 counts is significantly different from the 19 counts statistically. With the essence of algebra or essence of math, it is absolutely different. One is 19, another one is 11. Okay, but in statistics, whether they are different or not, 11 counts and 19 counts, I mean the frequencies. Okay, so you do a survey of 11 females, whether this count or this frequency is different from the 19 counts. All right, so there is no significant difference. I just make it a capital so that you may not miss this one, because this is very important. Okay, so there is no significant difference between the proportion of frequency data, okay, data frequency of classes in data frequencies between the classes, okay, of the classes, you can say, of, okay, classes in the variable. You can, okay, insert whether you have chosen a variable, a particular variable, please insert it here, okay, investigate it, okay. And for H1, you just change, okay, there is a significant difference between the proportion of each category, right? Okay. We are, or let's say, using the cars 93 data. Okay. Library mass, please load it. Okay. And then you say the data, or you can write in one time short. Okay. Okay. df equal data and open cars 93. All right. So it's quicker. Okay. So you can say df here, can run. What are they? So here df, okay, car, okay, df here. Or to make it a proper one, you can say like this, okay, cars to avoid errors, car 93s. Okay, to see the names, okay, and the nature of our data, we can use like head df, okay. So the head of df will show you, okay, here. I'll run it again, okay. So I enlarge. Now please tell me manufacturers, model, and type, the first, second, and third variable. What type of measure? Are they qualitative or quantitative? So these three. Everyone?
It's a qualitative types.
Jeanine said it is, or they are qualitative. Any different idea, or do you all agree? Okay, good. And the other that are qualitative as well is airbags, okay, and drivetrain, okay, front, rear, front, something like that, okay. And what else here? Main train avail, yes, no here, okay, also qualitative.
Origin, sir.
What is it?
Origin.
Yeah, origin, of course, okay, and make here, Audi, BMW, Black Century, whatever, okay. We practiced last time one variable, they're coded with number, but it is qualitative. I don't remember whether it's a cylinder or what. But anyway, there are many qualitative variables that we can practice. Now, please choose, or let's give me one qualitative variable that you would like to do comparisons. I mean the proportion, the frequency, whether there is a significant difference in their proportion or not. Please give me one. Give me one variable, please.
Manufacturer, doc.
Okay, let's see manufacturers. Acura, or Audi, or BMW, or Black Century, whatever, okay? Right? Okay. Okay. Focus. The manufacturers, or the variables manufacturers, okay? To see how many categories of manufacturers, we can say table, okay, and also the count. Okay, DF manufacturers. We can do a run. Oh, too much. Too many. Please do another one.
How about airbags again, sir?
Okay, let's see airbag again, right? So there are only three. Airbags. Okay. Table DF airbags here. Okay. We can do a run, all right? So we can see that the airbag for both driver and passenger, we have 16 counts. Okay, the distribution, the 16 counts, or we can say 16 occurrence. And driver only, airbag for just driver. No matter about the passengers. Okay, 43, and there's no airbags. There are 34. Okay, so we are investigating whether this frequency, okay, this frequency 16, 43, and 34, they are significantly different or not statistically. All right, so it's not that difficult when we do the chi-square. Okay, we can just use the chi-square. Okay, so the expected proportion among the three, could you or can you tell me what is the expected occurrence in terms of percentage for the three category? Okay, so there are three groups or three category. If you do not mention, or there is no given expected proportion of the distribution. So let's say expected distribution or frequency. What is it in terms of percentage? Okay, what is it? It is 1/3. 1/3. So the expected distribution or expected frequency, there is 1/3, 1/3, 1/3. It means if the distribution or if the frequency is around this proportion, there is no significant difference. Okay, right? So if there is no indication of the expected distribution, then we can just use chi-square dot test. Okay, and then you can say the table. Okay, table of the DF airbags. Okay, here. All right, and the result is there already. Chi-square test for given probability. Okay, so the given probabilities of our variables, if we have three category, okay, then the percentage for each of the category is what? The percentage is something like that. All right, or let's say no, 33.3, something like this. Is it correct?
Yes, Doc.
Right. So this is the percentage that it should be tested again, the chi-square, if we do not provide any indication. Okay. All right. And our result here, the chi-square value is 12.2, and the df2, it means df equal the n minus 1. 3 minus 1 is 2. Because we have three category. P-value. So how is it? The frequency here, is it different or not?
No significance.
No significant?
0.002.
Okay, so here is the frequency. So the frequency here we can see already, passengers and driver, okay, 16 here, driver only 43, and then for nanny 30, 34, okay, right? So our p-value here, 0.002. Then our tested frequency here, are they different? Are they significantly different? Different or not?
Yeah.
Yes?
Different answer.
Okay, good. Yeah, there is a significant difference. All right, good. That's simple. Okay. So, okay, based on the results of chi-square test, there, or you can say the frequency distribution of each category in the VAR airbags, okay, is significant different at the p value 0.002, right? And you can open a bracket, the chi-square value, okay, you can put it here. Okay, yeah, right. Another practice on the origin, okay. So we are testing whether the place where all the cars were made, whether the survey obtained an equal number of cars between the US or the non-US made. Okay. So we want to see the how many categories. So we say table, okay, DF and origin. Okay. So how many categories of the origin variable?
2, sir.
Yeah, 2 categories, or we can say another word, 2 factors. Yeah, in some cases you can say 2 factors. Like in the experimental agriculture, you have one group of the fertilizer of 1 gram, another group is 5 gram, another group is 9 gram. So we can say this is factors. Okay, all right. So the 2 category, one is US, another one is non-US. Based on these figures, US 48, non-US 45. Can you foresee the answer before doing the test?
The proportion is like 1:1, sir.
Excuse me?
The proportion is 1:1 or something like
Yeah. So it's different or not?
that. Maybe no, sir.
No.
Okay.
Possible.
Yeah. Based on these figures, the proportion it seemed to be 1:1. So the US is also 1. The proportion this is also 1. Okay. 48 and 45 in statistic, in particular in this counts. I don't think it is different. Okay. Let's see. So if there are 2 categories in a variable, the natural expectation of the distribution is 50-50, right? So like 50-50. Okay. 50%, 50%. Okay. 50%, 50%. Then you can do the chi-square test. Okay. DF, let's say table. We use table because our data is qualitative, and for chi-square, it compare the frequency, the occurrence. Okay, the number like for example 48. If you don't put a table, then it will not be able to do a correct way for chi-square. DF origin. Okay, you can see the p-value so big, very big, 0.76. Okay, and the chi-square value is very small. Okay, less than 0.1. It's 0.09, or let's say 0.1 already, but very small, right? Okay, so we can say no significant difference in their distribution. So this is the chi-square doing comparison using the qualitative data based on the frequency. Fundamentally, the quantitative analysis like chi-square, like like t-test and now ANOVA, or the non-parametric tests, they are also based on the frequency. Okay, fundamentally, but because there are too many for quantitative data for each sample, there are a lot of different numbers that can be calculated. Okay, but in order to do a calculation, fundamentally, it first need to assign the distribution or the frequency as well. Okay, but it's harder than the real qualitative. Anyway, I just don't want to talk more about that because we are not really in the theory of statistics. We just apply. So just make sure you apply the correct way, right? Okay, so this is just 2 category. Okay, 2 category, 3 category, the above one. Yeah, the airbags. Okay, so here, significant difference. Okay, for the chi-square, if you have 2 category or 3 category or more than 3 category, if you want to do a pair comparisons, okay, for example, driver, passenger, and driver only, okay, or none, something like that, you need to have a given proportion or given percentage. We can't do pair 1 by 1 like that, like the quantitative, but we can do the goodness of fit. Okay, goodness of fit. For instance, if you want to test, okay, if you want to test the quality or the preference of car to the passenger, I mean to the clients, regardless of the airbags, okay, then you may want to get a expected number of car built with airbag for both passenger driver, and expected number of car built with airbag for only driver and for none. Okay. For instance, I want to get all my survey. Okay, all my survey. I want 50% of car that have airbags for both. 50%. Okay, car for airbag only for driver, and 20% for none. So it is the expected distribution. And if we want to do a comparison to a hypothetical value, we can do the goodness of it. Goodness of it. It means we compare our survey data to the given distribution. Like what I said, okay? I want to test the distribution of each category of airbags. Airbags, okay, to a given distribution or proportion. Distribution. Okay, what I give an example. For first group, driver plus passengers. You still remember the percentage that I mentioned? That we want to test? Excuse me? How many percent?
1 over
33.33.
Again, please?
33%, 33.33.
No, that is the without given. Okay. So the three category, if we do not want to test again any value, any like a prior distribution provided, then we can just do this one. Okay. Without any given distribution. Okay. Without any given distribution, it is 33.3, 33.3. They are equal. All right. But if we want to test again a given value, okay, for instance, driver and passenger, I made an example that I want to collect 30%. Okay, in my data. Okay, and for driver only here, 50%. Okay, and for the for the none here, I say 20%. Okay, so if you want to do a test, compare the observed data or observed frequency of driver and passenger here to 30%. And the driver only to 50%, and last, the none to 20%, then we can have a different code. So chi-square test, the first argument is the same, table, DF airbags, okay? And then we need to put a P, okay? A P, it means probability. A P, probability that we want to test against. So C. So airbag, we can see first table here, all right? So airbag, the first driver and passenger. What is the percentage of D plus P? 30%. What is the probability? What is the probability? Probability. 0.3. All right. And 50% is point. Point what? Yeah.
0.5.
And 20%. Yeah, good. So we want to test our observed 16 for passenger and driver. Driver 43 to a probability of 0.5, and the 34 here, probability of 0.2. Whether there is a significant difference or not. Then we can run. Okay. So they are different. Okay. Still, and very much different here. Right? Okay. So the driver 16 here to a tested probability of 0.3. Okay. It is significant different. Okay. Among this. So this is called a goodness of fit, that we want to check whether our observed data, okay, corresponds to what we want in the previous time before doing the survey or not. Okay, an example is that. Okay, an example is that in your data collection, okay, in your data collection, for a class, an international class, that are whose origin are from Asia, another group are from Europe, another group are from America. Let's say like that. Okay, to have a more or less equally diversify, okay, diversify, we should have more or less equal percent of each group of students, right? If your class is all Filipino, is it international?
No, sir,
Yeah,
from
no?
local.
Yeah, not really, right? Yeah. So if you want to have a very well equally international student, so each region or each continent must have more or less equal number of students, right? So let's say, example, international student from 3 continents: Asia, Europe, let's say Europe, and USA. Okay, and your class, okay, the class you want, okay, the class you want is that each group of student from each continent, the number of student, okay, number of student from each continent is equal, or let's say relatively equal. Sometimes it's not exactly equal. The total number you want to recruit, let's say 50 students in the class. Okay. After registration, you got Asia, say 20. Okay. Europe, you got how much? 18. And USA, you got how much to 50? How much? How many? 12. Okay. All right. So for your analysis, you want to test against whether the real registration. Okay. So this is to test whether the real number of students registered for the class is reflective of your target, okay, target number. So the number to test whether the real number of students registered is reflective of your number or not, you do the test. So in this case, okay, here, okay, number of students from each continent is equal. And how many continents we are recruiting from? How many?
3, sir.
3.
Three,
So
sir.
right. So the probability of each continent is what? The student from each continent, the probability is point what?
Point two, point two,
No. This is the real one, the real registered. Okay. So after registered, you get this number. But before registration, you set a target. Okay. You set a target like this. Okay. From each continent, you
33.33.
Right. Excellent. Okay. So in our previous discussion, I mean, before the recruitment, your group or your staff discussed that we aim, okay, from each continent equal number of students, okay, more or less equal. We got 50 students. It means that the expected number of students from each continent is what? So expected here. So Asia is equal Europe equal US. US equal 50 divided by 3.
16.66 daw.
67.
What?
16.66 or 67.
16.60, yeah?
67.
67.
Or you can write down here. So 50 divided by 3 here. Yeah, okay, good. 16. All right, okay. So this is the expected, okay, expected number. So yeah, sometime maybe Asia like 17, yeah? And the other Europe 17 and USA 16, something like that, let's say, yeah. But the real number is here already after the registration. Therefore, we want to do a test. Whether is it significant different from what we expect or statistically they are the same. Okay, we can do the test. So chi-square dot test. Okay, or we need to form a observed numbers of student equal concatenate 20, okay, 18, and then 12, right?
12.
Yeah, okay. Then we do the chi-square of this one, okay, against our p probability c. So 0.333, right? And another one 0.333. and another 1.333. Is it correct?
Yes,
Yeah.
sir.
Good, because we have 3 categories. So each category must have the same probability. It is what we expect. So we test again this value, right? So let's see. Okay, error, chi-square, p-value. What is the problem here? Okay, probability, we test again. So here point, let's see. What is the errors? So number of students we have already here. P. So number of students we have, and probability must sum to 1. Oh yeah. So let's see like this. Because if we sum all together, will it equal 1?
1.99.
Yeah. So
0.99.
good. So we do like this: 1 divided by 3, and another one is 1 divided by 3, and another 1 divided by 3. So they are the same probability. Then we can run. Okay. So how is it? The observe and the expect statistically different or not?
No.
No. Okay. No, not different. So yeah, your class 2018-12, it is statistically, we can say it is an international class.
There's
Okay.
nothing.
Yeah, it's a good representation already in statistic. Okay, so if someone come and say, oh, it's not a really well international class because you have the US as 12, but you won like 16. Yeah, you can say, no, it is statistically. Okay, statistically, they are the same, not different. So it is a good representation of international student in your class already. So don't worry, right? Okay, so this is an example that we use qualitative data in order to do some comparisons. Okay, the distribution, something like that. Okay, good. Question?